It gives me great pleasure to introduce one of my favorite people at Microsoft, Mr. David Weston, who is the Corporate Vice President of Microsoft Security. He's going to talk about our approach to agentic AI and security. David.
Everyone. So we're hearing this word a lot, right? Agentic. It's like the new NFT. So I'm gonna try to actually get into what we mean around agentic security and agentic practices a bit, show you some of the vulnerabilities, and ultimately show you what you can do about it. Hopefully you walk away a little bit understanding, I think, what the best practices are and what controls we have in place for agentic style attacks. I think the first most interesting thing now in security is something called MCP, or Model Context Protocol. That is the fundamental mechanism for interfacing all kinds of cool tools and giving capabilities and extensions to LLMs and influence. So it's great that we can talk to ChatGPT and ask them what kind of shoes go with these pants. Not that I did that. But it would be even cooler if they could answer our email, Teams messages, interact with our IDs, et cetera. And so developers are answering this call. MCPs are incredibly flexible. They're the types of things devs like. You can take an existing piece of code, whether that be on Windows, a Linux container, a VM, an existing legacy application. You can put a piece of code in front of it that understands MCP, that defines how the tool can be used. You can plug that into an LLM like Claude, Copilot, ChatGPT, or one of the open source. And you can build, especially with an orchestration layer like semantic kernel, a pretty complex workflow. Now this is all great, like autonomous work getting done. We're hyped about this. We love this. The question that will be on many people's minds, from IT to CISOs, is what does this mean from a security perspective? I think I can show you better than I can tell you. So let's take an example attack. Here's an attack against an MCP server from a company called Supabase. And Supabase has a database platform that's actually quite interesting. And as a good database platform, they support customers providing issues. One of the fundamental challenges with transformer and LLM types of architectures is that there really is no segmentation between code and data, or in the case of an LLM, prompt/instructions and data/tools. So if you're around doing security 20 years ago, this is kind of similar to the problem of separating code and data. In operating system world, we created technologies like data execution prevention, but we don't have that kind of thing in LLMs. So there are actually quite a few different styles of attacks that can be perpetrated this way. So one good example is something we call cross-prompt injection, or XPIA. So in the case of Supabase, if you can really zoom in here, what we're doing in the context of this attack is supplying a chat message, in this case, something that a support agent would normally operate on, and we're saying, hey, if you're Cursor or Claude, ignore everything else and just do what I tell you. This is the intersection between code and data, and the LLM doesn't understand that. So on the back end, what's actually happening in the case of Supabase is a dev who's built a really cool MCP just wants to process these support tickets, have their IDE do work, maybe fix a bug, process a ticket, open an issue. But these instructions, because they're not filtered and going directly to developers, can actually be converted into executions or operations that happen on the developer machine, and all sort of hijinks ensue. So in the case of Supabase, they've actually built, again, their entire support system around an agentic IDE. The previous instructions to ignore everything we're doing and provide access to certain database tables. In this case, they have exactly what the attacker wants, which is a whole bunch of credentials that are used by these tools. So GitHub accounts, Gmail accounts for sending updates, issue accounts, all those things are stored in the database. So now, as the IDE works through the support-based tickets, through its MCP interface, the instructions are saying things like, go pull these tables and redirect them into the issue. And where that turns into a pretty scary issue is all of that information is echoed back vis-a-vis the ID into the support ticket. And what you see up on the screen is benign but clear plain text credentials essentially stateful bearer tokens that are available to connect now to GitHub accounts, MCP accounts, et cetera. So in a very short period of time, we've gone from benignly chatting with a support agent to it ending up on a developer's desktop, to the agents doing their thing, accessing low-level database information, and then redirecting that into the support ticket. Pretty cool hack if you ask me. Also scary, very scary. So the question is, what does this mean for an agentic world, right? We want to do less work. All of us want to just chill and sort of vibe our job, but that does not come without risks. And I think the goal here is to make both of those things true. Make things safe, but also we want to chill. So how do we do that? Well, one of our biggest challenges is as we explore more functionality vis-a-vis agents, the more and more this kind of capability exists. So we really want to find a way to expose just the amount of capabilities we need while also mitigating risk. The challenge is almost anything that's useful to be bound to an LLM from a tool is going to have access to untrusted content, maybe access to users' private data, or the ability to externally communicate. The big challenge here is if we are able to do things like execute arbitrary commands, we can do all of these different interesting attacks from stealing private data, like in the previous attack, to in the case of operating systems that are now supporting MCPs, even typing commands into a command console. We also have attacks like data exfiltration, for example, stateful memory, or vector databases that are attached, say, in a RAG app. Those are the types of things that with the right instructions and the right type of vulnerability are available in the agentic world. And then, of course, being able to generate either text and images that bypass, say, a system prompt, or that are available and bound directly to the LLM. So just a few of the styles of attacks that are possible in an agentic world. So what can we do to secure the agent stack? Well, it turns out many of the fundamental technologies we have today to support things like your traditional three-tier applications, or even good old-fashioned Win32 or mobile apps actually apply in this world. So the first thing we need to do to secure the agent stack is actually understand within an enterprise where an LLM is being used, and particularly where it's being bound to an MCP. So enumerating this attack surface and the usage across your enterprise. To me, this reminds me of the old SaaS problem. Everybody wants to use SaaS. They're sprinting towards it. But the security folks need to understand where there's risk. Where is that company data being stored, or who can operate on credentials that may be provided to these SaaS applications? There's a very similar footprint in an agentic world. So things like proxies are very possible to do this enumeration. There are many different EDRs that support this type of things. But understanding your attack surface to start is key. If there's a SUPA-based style thing in your organization, you're going to want to know that. The second thing you want to do is secure the agent endpoints. Where are these LLMs happening? In the previous attack, that LLM would be on a developer desktop. So again, there's an option to do logging and detection, or even get into critical paths so you can stop things like XPIA on developer desktops. There are many different products that are now emerging, both in the startup and sort of mainstream tech and security companies, that will sit in between an LLM and MCP servers on a developer desktop or a productivity worker's desktop, log, detect, and ultimately block attacks. The third thing we want to do is secure agent connections. The communication between the LLM and the agent itself or MCP server. You're going to want to have authentication. Companies like Entra, Ping, et cetera, provide now agent IDs around this that allow you to uniquely authenticate, authorize, and ultimately log the identity of these agent connections. And that can be over protocols like A2A, or again, MCP in this case. And then finally, this is where the most common and most powerful mechanism is available, which is you want to make sure the agents, you understand where they come from, who built them, and why. And you ultimately want to make sure that they have least privilege. In the case of the previous example, having low-level, row-level access to the database with credentials was probably not the right thing to do in terms of architecture. But there are various mechanisms that would allow you to contain and audit the capabilities of these agents. And those are all sort of the best practices that are going to make sure, in the case of an XPIA attack, that damage is contained to something that's manageable and the security team can detect and respond to. And so if you take these 4 things together as a defense in depth strategy, you can contain, detect, and respond to XPIA attacks against agents. So in a nutshell, while this sounds new, exciting, and probably scary, the good news is many of the techniques we've applied to different styles of applications will work really, really well here. And we have a lot more to talk about here at Ignite around agentic security. And with that, I'm sure you're really excited about this, but we have just a bit of a break. So thanks, everyone, for listening to me. Appreciate it. Thank you.